Welcome back, everybody. This is our video solution to problem 2 from Quiz 7, Spring 2023, Math 302 at Cal State Fullerton. And in this problem, hey, it says you'll be working in Zmod 24Z, so that's where we'll be working. So Zmod 24Z, right, this is a set of integers modulo 24. And in the first problem, it says find all of the units and zero divisors in this following set. Notice the square brackets telling you you're looking at the equivalence class for 0, 3, 5, 12, and 17. Okay, so it's just to make it explicit. So first, we're finding all the units. Yeah. So we had a resultant class that told us that if I have some equivalent class in Zmod 24Z, of course in class we didn't say 24, we just said M, then this class of A is a unit if the GCD of A and 24 is 1. And this is if and only if. Okay, so all we need to know is whether or not each of these representatives is relatively prime to 24. So let's see first. We have 0. 0 is not relatively prime to 24, right? The GCD of 0 and 24 is 24. 3 is not relatively prime to 24. 3 and 24 have GCD 3. However, 5 is relatively prime to 24. 12 is not. The GCD is 12 itself. And 17 is relatively prime, right? It's easy when 5 and 17 are prime, right? So we know that, we'll write it this way. The GCD of 5 and 24 is 1. And the GCD of 17 and 24 is 1. So this tells us that 5 and 17, or at least their classes, are in the set of units. Remember, we had this U symbol. Okay, the set of units for Zmod 24Z. Okay, now next, we are also asked to find the zero divisors. And, well, the important thing here, right, is that when you're looking at Zmod MZ, or in this case Zmod 24Z, but this works for any modulus, you actually break up the set of equivalence classes into just two partitions. You have the units and you have the zero divisors. So anything that is a unit is not a zero divisor, anything that's a zero divisor is not a unit, and anything that is not a unit is a zero divisor, and anything that's not a zero divisor is a unit, right? Like you're in one or the other. So we know that 5 and 17 are units. So the two remaining bits, 0, or 3 remaining bits rather, 0, 3, and 12, these are the zero divisors. Okay? So by process of elimination, or if you like, knowing that the GCD is greater than 1, right, we're going to know that 0, 3, and 12 are zero divisors. Okay, fine. Next bit, find the inverses for each of the units you found in the previous question. So we found 2 units, right? So we had 5 and we had 17. And because they're units, that means they have an inverse, right? You can multiply by another class and get the class of 1. So how do we do that? Well, let's just start taking, say, 5 and looking at its powers modulo 24. That's usually the easiest way to do this, right? So I do 5, and then I could do 5 squared. Now 5 squared, let's see, that's 25. Oh, but modulo 24, 25 is congruent to 1. Hey, there we go. So 5 squared is 1. So this tells us that the inverse of 5, what do you have to multiply 5 by to get 1, is actually 5 itself. Neat. Okay, what about 17? Well, 17, I don't want to start taking powers of that. I'm going to, before I take powers, I'm going to reduce it to the least negative residue. So I subtract 24 and I get negative 7. That feels a little bit better. So 17 is the same as negative 7. Now, what is negative 7 squared? Well, the negative goes away and I get 49. Oh, but now let's see. I can reduce this mod 24, and 24 times 2 is 48. So this is actually, again, congruent to 1 modulo 24. Cool. So once again, this is telling me that 17 squared is 1. And so actually, once again, the inverse of 17 is 17. Okay. All right. In case this is, going a little fast here at the end, how do I get from the square to the inverse? Okay. Let's recall, what does it mean to be the inverse? It's what you have to multiply by to get back to 1. Right? So in the first instance, we had 5 by 5. 5 squared is going to be equal to 1, right? Modulo 24. Okay, so this is what's telling me that the inverse of 5, what did I have to multiply 5 by to get 1, is exactly the class of 5. And the same thing is happening over here. And you might say, well, wasn't it negative 7? But of course, negative 7 and 17 are the same thing, modulo 24. Okay, so in each of these cases, they are their own inverses. Okay, very good. Well, we will see you next time in problem number 3.